Have you ever stopped to think about what keeps the internet from just falling apart? Seriously, because back in the early 1990s, it almost did. There was this hidden crisis brewing, something that threatened to stop the internet's incredible growth dead in its tracks. So let's dive into the story of the clever system that saved it all.
Okay, so the first chapter in our story is really a classic problem of being too successful. The internet was just growing way too fast for its own good.
I mean, just look at this chart. This curve looks fantastic, right? It's a sign of wild success. But what nobody saw coming was that behind this amazing growth, a massive, system-breaking problem was building up.
See, the problem was actually pretty simple. Every single device, every computer or host that connects to the internet needs its own unique identifier. It needs an IP address. But the system they had for handing out these addresses, well, it was built for a much, much smaller internet. It just couldn't keep up with the demand.
So, what was so wrong with the old system? Why couldn't it handle the growth? Well, it all comes down to something called the class system. And trust me, it was anything but flexible.
To really get what was happening, you only need to understand this one thing. An IP address does two jobs at once. The first part, the network portion, that's kind of like the zip code for a whole neighborhood. And the second part, the host portion, that's the specific street address for one single house. Or in our case, one single computer.
You know, the internet didn't start out this way. But back in 1981, a new standard came out, and it divided up all the possible internet addresses into three main buckets: Class A, Class B, and Class C. Now, this decision was made with the best of intentions, but it's what led directly to the crisis we're talking about. A crisis so bad, it needed a whole new system in 1993 to fix it.
And this chart here, yeah, it looks a little technical, but it shows the problem perfectly. The old system split all the addresses into just three rigid fixed sizes. Class A gave you a tiny network portion, but room for a ton of hosts. Class C was the exact opposite, and Class B was right in the middle. The key thing to see here is that there were no in-between options. It was incredibly rigid. So what did that rigidity mean in the real world? It meant you had these huge, totally impractical jumps in size. Let's say you were a growing company, and you needed, 300 addresses. You couldn't just get a couple of those small Class C blocks. Nope. Your only choice was to jump all the way up to a Class B.
And this is the crucial point. To get the 500 addresses you actually needed, you were forced to take a block of over 65,000. That means more than 64,000 addresses were just gone, wasted, assigned to you but never, ever used. And this was happening all over the world. The available addresses were just disappearing into thin air.
Now, this massive waste didn't just burn through all the available addresses. It was also creating a huge, messy problem for the internet's core infrastructure. You know, the routers that actually direct all the traffic.
Okay, so this is the before picture. In the old classful world, a world that only knew about A, B, and C, the routing protocols were kind of dumb. When one router would tell another router about a network, it didn't include the size of that network. The receiving router literally had to look at the first few numbers of the address and just guess if it was a Class A, B, or C. As you can imagine, that made routing things efficiently almost impossible.
The internet was in trouble. It needed a hero. And that hero came in the form of a brilliant new idea, a classless way of thinking called CIDR.
The genius of CIDR was all about one word: flexibility. It completely threw out those rigid A, B, and C classes. Instead, it used something called a variable length subnet mask, or VLSM. Think of the mask as a slider that tells routers exactly where the line is between the network part and the host part of an address. And because that line could now slide around, network admins could create custom-sized networks. You need 500 addresses? No problem. Here's a block of 512. All that waste was just gone.
And here it is, the triumphant after picture. With this new classless routing, the update that routers send to each other now includes the subnet mask. It includes that crucial piece of information about the network's exact size. No more guessing. Routers knew precisely what they were dealing with.
So let's put it side by side. The old way, classful, was blind, rigid, and super wasteful. The new way, classless, was informed, flexible, and incredibly efficient. It was a complete game changer for handing out addresses.
But here's the really cool part. CIDR did more than just save addresses. It had another trick up its sleeve, a kind of superpower.
that actually made the entire internet run faster and more stable.
And that superpower was called route summarization, sometimes called supernetting. Because routers could now understand any custom network size, they could do something amazing. They could take a whole bunch of smaller, individual networks and advertise them to the rest of the world as one single, big, summarized route.
And the way this works is actually really clever, and you don't have to be a computer scientist to get the basic idea. You just look at all your network addresses in their raw binary format, as long as strings of ones and zeros. You find the part of the string at the beginning that all the addresses have in common, and that common part becomes your new, summarized supernetwork.
Take a look here. You can see all these separate networks on the left. By finding that digital pattern they all share, a router can create one single summary route that points to all of them. It's like being able to replace 4 different street signs on a highway with a single, simple sign that just says, "This way to the Smith neighborhood." Much more efficient.
And what was the result of all this? Well, the big routers on the internet backbone suddenly got a huge break. They no longer had to keep track of every single little network out there. Their routing tables, which are basically their address books for the entire internet, shrank dramatically. And with smaller address books, they could look up routes and send traffic on its way much, much faster.
So when you step back and look at it, the legacy of CIDR is just immense. It solved the address crisis, it stopped the internet's core from collapsing under the weight of millions of routes, and it pretty much single-handedly bought the old IPv4 internet another 20 years of life.
CIDR was an absolutely brilliant patch, truly a testament to clever engineering that saved the day when we needed it most. But it was still a patch on a 32-bit system that was never, ever designed for the scale we have today. Which leaves us all with a pretty big question. As we connect trillions of new devices from our watches to our cars, how long can that patch possibly hold before we need something new altogether? Well, that's a story for another time.